All right, now we're going to look at adding and subtracting polynomials. And since we've learned a standard form, we're always going to make sure our answer is written in simplified standard forms. We've combined any like terms, and then it's in the proper order. Remember that like terms means they have same variable and same exponent. You have to have both to be like terms. So addition is much easier, so I'm glad we're starting with that one. So when we're adding, we can't actually do anything inside either parentheses because these are all different, x squared, x, and no x, x squared, x, and no x. So because they're all different, I can't actually do anything inside any of those parentheses. So then really I can drop the parentheses. I can just ignore them. And I'm going to look from each set and combine the like terms. So this is really hitting 1x and then 1x squared, and 4x squared is 5x squared. And then we have a 2x, and again hidden 1, so 1x makes 3x. And then we have a positive 7 and a negative 3, and that makes positive 4. And then if you're someone that struggles with those integer rules, I'm just adding every time. So I put in 7 plus negative 3 in my calculator. And then it's in standard form, so x squared, then x, and then the constant at the end. And then just a reminder, we're talking about degrees. This is a second degree, so it's a quadratic. It's got 3 terms. It's a quadratic trinomial. And the leading coefficient would be 5. Number 2, again, we're adding, so I'm just going to look for which ones have the same variable, same exponent. It's easiest if you just start with the biggest exponent first and go down. That way it's already going to be written in standard form. So I have a 5x squared plus a negative 2x squared. That's going to make 3x squared. And then I've got negative 2 plus positive 3. That's going to be a positive 1x. Or you can just write plus x. You don't have to write the 1. And then I have a positive 4 plus a negative 1. And that's going to be a positive 3. Number 3, again, we're adding. So because we're adding and there's nothing I can do inside either parentheses, and I can just ignore the parentheses. If we look in this one, though, I have an x to the third here, but I don't have one over there, which means that's going to stay the same. Anytime they don't have a like term, it just stays the same. So 2x to the third. And then I'm going to come over here next. That's my next biggest exponent. And it also doesn't have a match, so it's going to stay plus 7x squared. Then I finally do have a match. I've got a negative 5x plus negative 1x is negative 6x. And then, so I've done all these. All I have left is that positive 2. And it's not a bad idea to cross the numbers out as you go so you know what you've already used and what you still have to use. Number 4. Again, there's nothing in either parentheses I can actually simplify, so we can ignore the parentheses. And I'm going to start with the biggest exponent first. So that's going to be this negative 3x squared plus 4x squared is going to be 1x squared. But again, you don't have to write the 1 if you don't want to. And then I'm going to go look for my next highest x, which is going to be this one. So 2x, it doesn't have anything, so it stays 2x. And then we have a positive 4 plus a negative 7 is a negative 3. And if we were doing all the other information from the first lesson, our leading coefficient here is 1, and it is a quadratic second power trinomial 3 terms. So just like the first one was. All right, find the difference. This is where it gets a little bit trickier with subtracting. So we have a minus sign in between the parentheses. So there's nothing I can do inside either parentheses, but we can't just drop the parentheses because of the minus sign. So what that minus sign does is, if we remember our integer rules, like for example, if I have 1 minus negative 3, we can change it to adding only if we make this the opposite. That becomes positive 3. So that's what we're going to do with this. I'm going to change this to a plus, but it's going to make everything inside this second set of parentheses after that minus sign become the opposite. So that's negative n, or negative 1n, and negative 2. So I don't need that top part anymore. So now when I'm combining it with negative 1n and a negative 2. Okay, so I'm now looking for my like terms. I don't have an n squared, so that's going to stay 5n squared. But then I have a 2n plus now negative 1n is positive 1n, or positive n. So those are gone. Then I have a 3 plus negative 2, and that's going to be a positive 1. Number 6, so again I'm going to turn this into a plus, and then everything in the parentheses after that becomes the opposite. So what we're actually doing is there's a hidden 1 here, and we're distributing negative 1 to everything. So negative 1 times 4x squared is negative 4x squared, and negative 1 times negative 1 is positive 1x, and negative 1 times 2 is negative 2. So we can see that it's changed. 4 went from positive to negative. Negative 1 became positive 1. Positive 2 became negative 2. So it makes everything change to the opposite. And then we no longer need that top part. Then we combine my like terms. So a 6x squared and negative 4x squared is 2x squared. And then negative 4x and 1x makes negative 3x. Because again, we're adding, so I would type in my calculator negative 4 plus 1. So I'm typing in this number plus the next number. And then the last one, 6 plus negative 2 is positive 4. Number 7. So I'm just going to, instead of doing all the distributive problem, I'm going to use a shortcut. This becomes plus. Now everything inside becomes the opposite. So negative 3x squared, positive 2x, and negative 3. It's never going to change the first parenthesis. It's only going to change what comes after that minus sign, because we're distributing, is why it's only after that parentheses, or after that minus sign. So now I don't need this top part anymore. I have 8x squared and negative 3x squared, and that's going to be 5x squared. And then the 2x doesn't have a like term, so it's going to stay positive 2x. Then I have a 2 and a negative 3 is negative 1. And then I already used that also, so I used everything, I'm done. Alright, so again here, we're going to change this to plus. So again, it's like distributing that negative 1 to everything, so everything's going to be the opposite. So that's going to be plus, now that's going to be positive 5x squared, negative 3x, and positive 7. So I don't need that top part anymore. Negative 2x squared and positive 5x is going to be 3x squared. And again, what I'm putting in my calculator is negative 2 plus, I'm always wanting to add, because I have a plus sign here, positive 5. Then my next one, negative 7x plus negative 3x is negative 10x. And then negative 3 plus 7 is positive 4. All right, for our last problem, we're going to look at some geometry applications. So it says write a polynomial in simplest standard form, so like we've been doing, and we're in the correct order, for this shape. So we want to find the perimeter. And just a reminder, perimeter is a distance around. So we add all the way around. Like if I had a problem like this and I'm looking for the perimeter and it was these numbers here, I would just add 5 plus 3 plus 5 plus 3 and add all the numbers. So we're going to do the same thing here. So I'm going to take the first side, 5x, plus the next side, 4x minus 1, plus the next side, x squared plus 2x plus 4, plus the last side, another 4x minus 1. And it doesn't matter which side you start with. Just pick a side as long as you have all 4 sides included. And now I'm going to go through and combine all like terms. So I only have a single term that is an x squared. So I'm going to start there. So that x squared is going to go first. And then I have a lot of x terms. So I have a 5x plus a 4x, that's 9x, plus 2 more x's, 9, that's 10, 11, and then plus 4 more is 15, so it's plus 15x. And then I have a -1 and a +4, that's 3. 3 and another -1, or 3 minus 1, is 2. And I cross-mouse, I went that way I can see that I used all the terms there. Okay, so we wrote it in standard form to represent the perimeter. Then determine the perimeter if x equals 3. So now I'm just going to plug in 3 for x. So 3 squared plus 15 times 3 plus 2. So we plug in the 3 everywhere we see an x. That's going to be 9 plus 15 times 3 is 45 plus 2. And then 9 plus 45 is going to be 54 plus 2, and we get 56. So if x is 3, the perimeter would be 56. So just remember when you're doing subtracting, that's the tricky one. When you're doing subtracting, you want to change it to adding and make everything inside those second set of parentheses, with the one after the minus sign, the opposite.